Okay, good afternoon. My name is Aaron. I'm coming from Embedded Technology. Today I'm sharing our experience of telecom usage on Ceph and the experience of upgrading their Ceph and scale their Ceph in a mixed mode of ARM server and operating systems. Okay. Okay. The contents I will show you is about an initial Ceph cluster building the first Ceph cluster in building a telecom company, which is one of the biggest telecom company in Taiwan, and how they meet their problem when they grow up their users, and how could we analyze the problem and finally decide how to solve the problem. Okay, so the detail I will show you later. So first of all, I would like to introduce our company, use 2 pages, introduce the company and the products, so you can understand what I'm talking about later. Okay. Embedded Technology is a company that provides the Ceph appliance, which integrate purpose designed for Ceph ARM server, and we also use not only the community Ceph, but also the SUSE enterprise storage. On above of that, we also have a management GUI, which called UVS Manager, let us to give the customer support tools and make the customer use the Ceph quite easily. Yeah. And the company was, we were a start company, start to promote this product starting from 2015. And we are, the product is a award winner that's provided by the 2016 Best of Interop in United States and Best Choice Golden Award in Taiwan Computex. And the second page is about products. The product, because it is quite special, that to make it easy to understand what I'm saying next, so better to have an idea about what it is. The appliance is based on a microserver architecture. Instead of using a big host of server host to host many OSDs in one server, we design to use one microserver based on 64 bits and host only one hard drive and one SSD for the journal. And any node can be configured as any OSD can be configured as an OSD, monitor, or MDS, right? So, so it is quite easy to deploy a Ceph cluster, even you have one single node to be a high availability Ceph cluster. Okay, so the customer background is one of the biggest telecom company in Taiwan. Because of the competition pressure from the market, so the telecom, they have to change their mind that by migrating their legacy cloud, which use VMware or other many very expensive storage to be open source. So that's a big change in a telecom company. You know, they are quite conservative because they are mission critical service. So they decided to start with their internal use private cloud, because they have two kinds of cloud. One is for public, that's a public cloud for most of the telecom customers. But instead of mass production for the critical public cloud, they decide to have a small scale and grow up to a big one inside their organization. So they decide to develop their own built OpenStack cloud based on the OpenStack and their own developed cloud management portal. That's their main focus. In the beginning, they also decide to build the Ceph storage by themselves, but that is not an easy job. They don't have also enough resource to make it work well. That because of the storage cannot be smoothly be used. So the project was delayed for almost 3 to 4 months until they found us to help them to quickly resolve the problem. Okay, so this cloud start with a small cluster, but they want to make it grow and push the internal users move their internal service to this OpenStack cloud. Yeah, so that's the company policy to save their cost for the future. So it's very important project in the telecom company. And after 6 months of production, they push their internal department users to put their internal services, migrate their VM to this OpenStack cloud. And in short 6 months, they moved around 140 VMs. But that is gradually move, not move all 140 at a time. But when they starting more and more grow to 140 VMs on this cluster, the users starting to complain. The service become slow because they have a lot of service internally. So even that is a private cloud, the users give them a lot of pressure. So we have to find them what's the problem. We don't know they put so many VM on this OpenStack cloud with the Ceph, because the Ceph we built is only 21 OSDs. That is quite a small cluster. Yeah. So when they find us to find the problem, we certainly know they are stressing the Ceph cluster very hard. Yeah, 21 OSD work for 140 VM. That's cannot be imagined. Yes, but we cannot just tell them that you are pushing the Ceph class too hard. But we can use the log, numerize the data to show them how the Ceph cluster is working. So first of all, we check the log of the Ceph throughput and the IOPS for certain days, like a week. We check the log. So we find that the read and write throughput is quite low. For example, you can see the read is about less than 10 megabytes per second. And the write is maximum 120 megabytes per second. So throughput is not the issue. Then we check the IOPS. Okay, so, but we find the IOPS is quite high. For 21 OSD, we can see the average is about 3,000. This is like 3 days log. And maximum can reach to like 7,000 IOPS. So we can see this is why the cluster is quite busy and slow, got a lot of slow request report from the Ceph cluster. So the major problem is on the IOPS. It's quite clear. We also checked two of the 21 OSD because the Ceph, the previous number is get in between. There's a cache in between, so we don't know. We cannot say by this number to show that hard drive is overloaded. So we have to check other numbers. What we check is the disk IOPS. We get log from every disk. From this graph, we can see that two of the, which just showed here, two of the 21 OSD disks in 5 days average. Every OSD keep always above 100 IOPS all the time. Yeah, and the maximum IOPS on each disk is 180. So that's already very clear that the OSD are overloaded. And this is the log for all the OSD in 1 day. Tells the similar information that the OSD disk, this is without the cache data, is over 100 IOPS every disk, all the time. And then certainly we have to check also is that the problem from the disk or CPU, how CPU is utilized. It shows that the CPU is quite easy. There's the utility of the usage of the CPU is less than 50. It's about 40 on every CPU. Yes, and but the CPU load we can find always has several tasks. The CPU load always have more than one task is queued, waiting for the CPU to CPU is waiting the I/O. So that's very clear that the bottleneck now is on the I/O. So even our node processor is a 32-bit ARM. The CPU utility is still very easy, but the problem is on the the hard drive. So we can know that from the log that at the level of the layer of the Ceph cluster, the IOPS is about 200 IOPS per OSD. This is quite high, and the total peak IOPS of the cluster is 7,000. So from this layer, we can tell. And also from the hard drive, the IOPS is very high. Yes. And average the IOPS shared to a single virtual machine, you can see that's only 28 to 50. That's obviously make the VM operate very slow. Yes. And besides that, we also collect what is the ratio of read and write, and what is the size, average size of the block. So we can see that 60% of the operation are right in their use case, and the average block size is about 20 to 40 kilobytes. So that's also make the hard drive very overloaded. Okay, so I think I missed one page. Let me check. Yes, okay. This is the initial cluster that we built for this telecom company, that we use three of our product called MAS 200. That's our previous generation on server, which has 8 nodes in each chassis. And one of the nodes in each chassis are configured as the monitor. And 7 of the other nodes, we configure them as the OSDs. And every chassis, there are 4 by 10 gigabits Ethernet connect to the top of the rack switch as a redundant high availability configuration. So you can see each chassis, there are 4 by 10 gigabits. And so this is the original deployment. And they are the Ceph version is on Joue 10.2.10. And the operating system is Debian. They use the Replica 3 as the pool for their Cinder, GANs, and Valent. Okay, so let's back to the solution. So the short-term solution is that they have spell servers, so they quickly deploy another 15 OSD into this cluster to release the load of the every OSD. So after we add the 15 new OSDs, there are also the Joule version, and it becomes 66 OSDs. So after we add the OSD, we can also monitor and check how the OSD load after we add more OSD into the cluster. So now, after that, we can see this is before expand. The OSD average is about 100. And after we add another 15, you can see the black one is the average. So always keep around under 50 for those VMs. Because this is one of the solution to expand. They also remove some testing VM, about 25 out of the cluster. So this after this is still about 115 VMs in the cluster, but the cluster loading is a lot of released. So we can see after we add the OSD. Okay, but for the long-term solution, they would like to also add another more OSDs, more servers, because their VM grows quite fast. Because that is the company policy to push the internal applications all move to the OpenStack. So the plan is that to add another 3 units of our on server, but that is the new generation of the 64-bit on server. And then we have mixed generation of hardware. But the other problem is that our new Ceph appliance MAS 400 is running the newer version of Ceph, which is Luminous, with the BlueStore. So there are some options to choose. One is keep using our old generation server, but still using the Joule without just upgrading the software. But this is not the good choice, because finally they will meet the problem that new Ceph version will come out, they cannot just stop at the Joule. So we decided to add the new hardware, which is 64 bits, to the cluster. But there are some issues that we will meet by mixing this. The advantage of this is that this allows the customer in the future can all follow the pace of Ceph version migration. And also the old version of server can also use better performance BlueStore. And also our user interface can also migrate to the newer version which support the Luminous, because the Luminous and the Joule has little difference. So the software is separated. Okay. So after this, we review why they made this kind of problem is that they have no experience and plan in the beginning that to plan what is the size of their cluster, because the Ceph cluster is scalable not only on the capacity but also the performance. So when they start to plan their first Ceph cluster, they didn't think about the IOPS they required for the VM, but only they think about the capacity. So that makes the problem. So we tell them how to plan their IOPS. Okay. The number that's based is on our hardware that we have row IOPS per OSD. This is what we know. If it is 100% read, every OSD we can get 700, and every OSD we can get almost 300 IOPS on 100% write. And because their load is more on the write, and the write also have overhead on replication. So based on this, we can also get the total IOPS after at least kind of workload. Then we can get read is 2 every OSD can contribute this number of IOPS. So the phase one that is the problem one, that they only get 49, less than 50 IOPS per VM. And the phase two, when we expand another 15, they get double the IOPS for the VM. That's certainly release the workload. And for the phase three, we plan to add another 21. So by this, we can know that if every VM plan to have 100 IOPS, they can finally reserve the capacity for VM up to 180 VMs. But for the challenge of the upgrade to expand the new hardware and the new Ceph version, there are several challenges we have to meet. First of all, that we have to upgrade everything without interrupt the service. They cannot stop the service for the upgrade. So, and then second is even the upgrade will not heavily impact their service, but we still want to shorten the migration period, because there are 35 OSD in Joule FileStore will upgrade to the Luminous BlueStore. That takes time. and we have to set strategy to shorten this period. And because our new 64 bits ARM server use the CentOS as its operating system. The previous one is Debian, but the new generation is CentOS. To unify the management user interface, so we have to not only migrate the Ceph, but also we have to change the old server operating system from Debian to CentOS. That's another challenge. Okay, so this is the target of the migration. Originally, we totally have all of the OSD on ARM32 and Debian, and all of them are Joue with Debian operating system. We want to migrate them or to the CentOS operating system and Luminous with the BlueStore, and mixed, also expand some of the OSD with our 64 bits ARM. Certainly they are the CentOS and the Luminous. The standard migration of the Ceph, even from Joue to Luminous, is quite simple. The standard is that upgrade the monitor first and restart the monitor. And then you upgrade the OSD node and then migrate FileStore to BlueStore. The first two is quite simple. The third one is just take time. Yeah. But this use case cannot follow the standard procedure to upgrade. First, we have to upgrade the web UI to our newer version, and there are two options to migrate the cluster of the monitor. When migrate the cluster, we have to upgrade the monitor first. Okay, so there are two options to migrate the monitor. First is that we migrate directly on load 3 old monitor from, at the same time, the Luminous to the Luminous version, and also replace the OS. But this is more risky, we think. So we decide to use another strategy, that is to add another 2 new nodes, which is on 64. But it is Joule version before upgrade to the Luminous. So after we add these 2 new monitor on Joule, we can kill those old nodes and migrate that to newer version. Yeah. So this give us less risk. The migrate steps is quite many steps, but the very important is that because we are killing the old monitor after we add another 2. So we have to change the client-side Ceph configuration file to add new monitor nodes, host and their IP address. So that's when we kill the old monitors, the client side will still find the cluster monitor. To make this easier to understand, I use this to explain. So in the beginning, we have 3 monitors in Joule and old web-based UI. And also the important is that the NTP is running on one of the monitor. So to migrate this, we have to first to add one new monitor on CentOS, but it is Joue version. We add another one, so now totally we have 5 Joule monitor in a cluster. After that, then we can start to kill, delete those old monitor nodes. But before that, we have to change the NTP server from the old monitor node to the new monitor node. And then we kill one by one. After we kill that, then we can, we still have 2 monitors in the cluster. And we can start to use our new version of Web UI. But the next step is to migrate these 2 monitors to the Luminous version. So we migrate one by one the 2 monitors to Luminous. And after that, we also add upgrade these 2 monitors is kind of easy. That we install the upgrade RPM and upgrade the Ceph version, then we restart the monitor, then they become the Luminous version. And at this moment, the cluster become a Luminous version. Even the OSD are still in Joule. After we add back all of the, we migrate the old hardware and totally change the image and let them to join the new monitor with CentOS and the Luminous. So after that, the Ceph become a Luminous version. Even there are still, all of the OSD are still keep in the Joule version. And now we have 5 monitor in the cluster. So after that, we can check when we delete the monitor, and finally the version of the monitor become Luminous. And we also can check the version of the cluster. It become, after we upgrade those monitors, they become the Luminous version as well. But the OSD are still keeping in the Joule version. Okay, so finally, we have to migrate those old OSDs. But before we migrate those old OSD, we have to add a new OSD to the cluster that make the cluster have more OSD to help the cluster to be rehealed when we remove the OSD. So after we add 21 new OSD, totally there are 57 OSD mixed with Joule and the Luminous. And the raw usage are about 60 terabytes in total. And there are 2 options to migrate the OSD from the Ceph document. One is to mark out the old OSD and recreate it with the new version. It is more simple and less risky, but the data have to move twice in the network. When you remove it, you have to wait it reheal. Then you can use after the cluster become healthy, you can add that OSD back with Luminous. This is the first option. And the second option is to use an extra host, but swap the data from the old OSD to the new OSD. This is like a disk copy, one by one. Yeah. And we decide to choose the option 1 is because we think this will be faster, because there are, when we delete one OSD, we still have 56 other OSD will keep reheal the PG. And when you add back, there are also many OSD can help to backfilling the data. So we think this is more faster than the second option. And this is the flowchart to show the loop. We use the Ansible Playbook to help us to do the total migration. So the flow is that first we remove one OSD from the cluster. Then we wait the PG backfilling become recovery until the total cluster become healthy. So this take about an hour for about 1 terabyte reside in every OSD disk. After the first OSD is removed, then we can replace the OS and the Ceph version and make that OSD rejoin the cluster. So after this reboot, then we have migrate one OSD. After the new OSD was joined to the cluster, you still have to wait the backfilling data migrate to the new joined OSD. So this one also take about an hour. So this is one cycle to mark out one OSD and migrate its operating system and Ceph and make it join the cluster again. So totally we have make 36 loops of this. So after, if there is any error, we can just stop to do the next step. So the Ansible playbook will check everything, every step before it go to the next step. So totally, we use about 108 hours to migrate those 36 OSDs. And every time, we only delete one OSD. So that will reduce the impact to the service to the minimum. And because the design of the every OSD has its own processor and server, that this also accelerate the migration of the OSD to be shortened, so that we can migrate all of the OSD less than 5 days. But if this is not in a microserver design, it may be different. For example, when migrate every host, it will affect not only one OSD, and it will affect multiple OSDs. That makes this more impact on the service. But I have no idea how about a big node. If they recover 36 OSD, will take how long time to recover. Maybe this, if you have the experience, you can share with us. So this is the whole migration process that we made in this use case to share with you. Yes. So any question? Okay. So thank you for your time. Thank you.